Hello everyone, good evening to everyone. I am Rajveer Singh, your biology teacher. Today we are presenting the fourth part, respiration, exchange of the gases. And this is the last part of this chapter, and I hope you will enjoy this chapter, same like our previous session. So, first question at front of you, just enjoy to it. Lungs are enclosed in peritoneum, perichondrium, pericardium, pleural membrane. Answer will be pleural membrane. Why? Because pericardium just used for cardiac part. Perichondrium just used in a muscles fibers. Peritoneum is also used in muscles, but pleural membrane is the just a part of the lungs are enclosed. Okay, so answer will be fourth. If I more talk about explanatory part of this question, so each lung in the is enclosed by a double-layered serous membrane called the pleura. The visceral pleura is the firmly attached to the surface of the lungs at the ileum. The visceral pleura is a continuous with the parietal pleura that lines the wall of the thorax. So answer will be fourth. Pleural membrane is the right answer. Next question, which is about when a person breathes air through the tube directly into the trachea, tracheotomy, it may lead to serious lungs crushing and infection due to cooling effect, drying effect, non-filtering effect, all of this. Answer will all of this. Why? Because all factors are right regarding of this in this such a situation. Okay, so let me explain in detail. So, in a tracheotomy, the tube is inserted through a cut in the neck below the vocal cord. This allows air to enter the lungs, right? Breathing is done. This then done through the tube by passing the mouth, nose, and throat. Air from your nose and mouth passes down through your throat to the larynx and into the trachea. Okay, then after the trachea is the big air tube leading to the lungs. When you breathe out, air leaves your lungs through this tube. Hence, during tracheotomy, a tube inserted directly into the trachea, colder and drier air enter the lungs than normal, which can cause lungs crusting and infection. The primary cause for this is air does not flow through the nasal passage way. So we can say our answer for this is a perfect our for this question. Next question about a pitch of the voice is lower in a male than female as the vocal cord of a man are thicker and longer, thinner and longer, thicker and shorter, thinner and shorter. So you should know about all. First of all, the vocal cords definitely may be thick, not maybe, that will be thick and longer also. Okay, so that is why our answer will be first. First option is the right answer. Next one about the description of this answer. So, the larynx is also called the voice box. It is located between the pharynx and the trachea. It has a framework of a cartilage that protrudes in the front of the neck and sometimes is referred to as a Adam's apple. Right? The larynx is considerably larger in the male than in the female. Hence, the Adam's apple is a much more prominent in the male. Is it fine? At the upper end of the larynx are the vocal cords, which serve in the production of a speech. They are set into vibration by the flow of an air from the lungs. A difference in the size of the larynx is that account for the difference between the male and female voice. Because the man's larynx is a larger than a woman's, his voice is a lower in a pitch. So answer will be first. Right? Next question. Which of the following statement is not true for a man? Forceful expression is an active process. Mammal have a negative pressure breathing. Internal, intercostal, and abdominal muscles are muscles of the forceful inspiration. Respiration excrete CO2, water, and etc. So, what should our answer? Answer will definitely third. Internal, intercostal, and abdominal muscles are muscles of the forceful inspiration. Is a not true for the men because forceful expiration is an active process. Mammals have a negative pressure breathing. Internal, intercostal, and abdominal muscles are muscles of the forceful. Normal, it means here not should be forceful. It's a normal inspiration. So that is why this sentence was wrong. And that is why respiration excretes CO2, water, etc. So you should know about all this expression just are giving to you more many right concept, right options in form of the explanation, right? So I hope you will understand everyone. Next question: the ventilation movement of the lungs in the mammal are governed by muscular wall of lungs, diaphragm, costal muscles, both second and third. Answer will be fourth. Diaphragm and costal muscles is the right. Why? Because the relaxation and contraction of the diaphragm and the movements of the costal muscles present in the thorax of an individual are responsible for the ventilation movements of the lungs that facilitate respiration. So our answer will be fourth. Okay. Now, next question at front of you. In lungs, the air is separated from the venous blood through transitional epithelium of alveoli, squamous epithelium of the blood vessels, squamous epithelium of alveoli, endothelium of a blood vessels, squamous epithelium of alveoli, and cuboid and cubical epithelium of the blood vessels, cubical epithelium of alveoli, and columnar epithelium of the blood vessels. So our answer will be second. Squamous, squamous epithelium of alveoli and endothelium of the blood vessels. So this one is the right. Because alveoli are the primary sites of the exchange of the gases. Exchange of gases also occur between blood and tissue. Oxygen and carbon dioxide are exchanged at these sites by simple diffusion, mainly based on a pressure, concentration gradient, solubility of the gases, as well as the thickness of the membrane involved in the diffusions are some important factor that can affect the rate of the diffusions. The diffusion membrane is made up of three major layers, namely the thin squamous epithelium of alveoli, the endothelium of the alveolar capillaries. However, its total thickness is much less than millimeters. So answer will be second. Next question is which of the following volume or capacity of the lungs cannot be measured directly by spirometer? Residual volume, functional residual capacity, total capacity, all of this. Answer will be all of this because neither RV nor FRC, functional residual capacity, and also total capacity can't be measured directly by spirometer. So answer will be fourth. Okay, so spirometry meaning the measuring of the breath. Okay, so measuring of the breath. The inspiratory capacity, IC, is the amount of the air that can be inhaled after the end of the normal expiration. B. Residual volume, RV, is the air remaining in the lungs after a maximal exhalations. Naturally, the residual volume cannot be determined directly using spirometry since it is not possible to measure the remaining air volume after maximum respirations expiration. Okay, expiration reserve volume, ERV, is the maximal volume of a air that can be exhaled from the end expiratory position. D. Inspiratory reserve volume, IRV, is the maximal volume and that can be inhaled from the end distal volume. So what you should know about spirometry can't be meanings the measuring of the breath, not a volume and capacity. So I hope you will understand why we cannot measure these all things, RV, FRC, and etc. Okay, now next question about amount of the air left in the lungs after the normal expiration is what? Residual volume, inspiratory reserve volume, expiratory reserve volume, functional residual capacity. So dear student, look here. When we are talking about just a normal expression, then definitely we can say this is the FRC. It means functional residual capacity. Okay, so why? The volume of air which remain in the lungs after a normal expiration is called FRC, functional residual capacity, right? It is also equal to the expiratory reserve volume and residual volume. It means RC, residual capacity means ERV plus RV. At FRC, the opposing elastic recoil force of the lungs and chest wall are in equilibrium and there is no excretion by the diaphragm or the other respiratory muscles. So answer fourth is the right answer. Next one question is the a minute volume of a respiration MVR in a person can be defined as tidal volume into breathing rate, tidal volume minus anatomic dead space and into breathing rate, vital capacity upon breathing rates, vital capacity upon tidal volume. So answer will be first. Tidal volume and breathing rate is the right answer. Okay. So MVR. First of all, we will talk about MVR. MVR is the minute volume of respiration. Is also known as the minute ventilation VE and is the volume of the gas inhaled or exhaled from the person's lungs in a one. Tidal volume is essentially every breath a person takes. It is one of the main determinants of a minute ventilation and alveolar ventilation. Minute ventilation, also known as a total ventilation, is a measurement of the amount of air that enter the lungs per minute. It is the product of a respiratory rate and the tidal volume. Alveolar ventilation, on the other hand, take physiological dead space. Is it right? Dead space into account. It represents the volume of air that reach the respiratory zone per minute. So, minute ventilation, it means respiratory rate and multiplication of the with tidal volume. Is it fine? Then in other hand, if I talk about alveolar ventilation, so this one is the respiratory rate multiply with tidal volume minus dead space. It was subtraction of TV minus dead space. Okay, so that is why we have choose the tidal volume multiply with breathing rate. So our answer is the first. I hope you will understand. Then next question about when CO2 concentration in a blood increase, breathing becomes shallower and shallow. There is no effect on breathing. Slow and deep, faster and deeper. Answer will be yes, fourth. Faster and deeper is the right answer because you can see here in description part the increase in the carbon dioxide concentration in blood increase the rate of the breathing. The increase in carbon dioxide brings it a remarkable changes in the pH of the blood. This change is sensed by the chemoreceptor of the medulla oblongata of the hindbrain, which has a regulatory center of for a respiration. The respiratory center increase the rate of the respiration to exhale the extra carbon dioxide and inhale more oxygen. So answer will be fourth. Is it clear? Now, then next question. This is very again very good question in point of view of CO2. So the constant CO2 carbon dioxide content by volume in the atmospheric air is about 3.344%, 0.0314% and 0.34%. Answer will be third. Because you can see here the carbon dioxide present in the atmosphere is generally the result of the respiration by animal during the day and the emission by the various vehicle, industry and machine. All these activity account for a total of the approximately 0.04% CO2 in the atmospheric air. So that is why our right option is the third. Next question about although much CO2 is carried in blood, yet blood does not become acidic because why? CO2 is continuously diffused through the tissue and is not allowed to accumulate. This is not right. Then CO2, transport, blood buffer play an important role. Yes, this definitely this is the right. This is right answer. Then CO2 is absorbed by leukocyte. This is not a strong reason. CO2, carbon dioxide combined with water to form H2CO3, which is neutralized by sodium carbonate. Yes, this will not absolutely right. So we can say our right answer is the second. Okay, so if I explain this option, so here I would like to say in favor of the second option, although much CO2 is carried in blood yet, blood does not become acidic because of the buffering action of the blood. Is it fine? Due to blood buffering, it does not become acidic in spite of the presence of the large amount of CO2. The main buffer present in the body is bicarbonate. Bicarbonate exists in equilibrium with carbonic acid, which in turn can be converted to carbon dioxides and water. So here you can see when we use reactant H2O CO2, then they will become carbonic anhydrase, and this carbonic anhydrase will separate in H plus HCO3 minus 1. So our option second is the right. Next one question. The carbon dioxide is transported via blood to lungs in combination with hemoglobin only, dissolved in blood plasma only, in the form of a carbonic acid only, as a carboaminohemoglobin and bicarbonates. So answer will be fourth, as carboaminohemoglobin and bicarbonates, because the majority of carbon dioxide molecule, 85%, are carried as a part of the bicarbonate. As I told you in just previous part also, already right. And here, buffer system. In this system, carbon dioxide diffuse into the red blood cells, carbonic anhydrase Ca, H2CO3, right? Within the red blood cells quickly convert the carbon dioxide into carbonic acids, and carbonic acid is an unstable intermediate molecule that immediately dissociate into bicarbonates ions HCO3 minus 1 and hydrogen H plus ion. Since carbon dioxide is quickly converted into bicarbonates ion, this reaction allows for the continuous uptake of a carbon dioxide into the blood down its concentration gradient. It also results in the production of the H plus ion. If too much H plus ion is produced, it can alter blood pH. Is it fine? However, hemoglobin binds to the free H plus ion, limiting shift in the pH. The newly synthesized bicarbonate ion is transported out of the red blood cells into the liquid component of the blood in exchange for the chloride ion. This is called the chlorine chloride shift. When the blood reaches the lungs and the bicarbonate ion is transported back into the red blood cells in exchange for the chloride ion, the H plus ion dissociate from the hemoglobin and binds to the bicarbonate ion. This produces the carbonic acids intermediate, which is converted back into the carbon dioxide through the enzymatic action of the Ca. Then after we can say the carbon dioxide produced is expelled through the lungs during exhalation. So answer will be fourth. Okay. Now next question is the how does the transport of O2 and CO2 by blood occur? With the help of the Wvcn blood serum, with the help of the platelets and corpuscles, with the help of the RBC blood plasma, with the help of the RBC and WBCs. So what will answer? Answer will be right. RBC and blood plasma is the right answer. Because the following diagram showing the transport of the O2 and CO2 alveoli and tissue fluids. Okay. And then after we can say the alveoli PO2 is a 104 mm of Hg and PCO2 is a 40 mm of Hg. In deoxygenated blood, PO2 is a 40 mm Hg, which is less than a partial pressure of the oxygen in a alveoli. Due to this, oxygen enter the blood in alveoli, right? And deoxygenated bloods, PCO2 is a 45 mm of Hg, which is more than partial pressure of CO2 in alveoli. Due to this, carbon dioxide exists from tissue cells and enter the alveoli. Once blood reach the tissue, partial pressure of oxygen in oxygenated blood in 95 mm of Hg, which is more than partial pressure of the oxygen is deoxygenated blood 40 mm Hg. Hence, oxygen from blood enter the tissue. At the tissue level, the partial pressure of the carbon dioxide in deoxygenated blood is more than that is of deoxygenated bloods. Hence, carbon dioxide exists from the tissue. Okay, so that is why our answer is the third. Next question is very good. Blood analysis of a patient reveal about So, blood analysis of the patient reveal an unusually high quantity of carboxyhemoglobin content. The patient has been inhaling polluted air containing unusual high content of what? Carbon disulfide, chloroform, carbon dioxide, and carbon monoxide. So, answer will be fourth. Carbon monoxide is the right answer because here you can see the carbon monoxide combines with the hemoglobin far more readily than O2. CO has about 200 times greater affinity of for hemoglobin as compared to oxygen, forming a relatively stable compound, carboxyhemoglobin. This causes low supply of O2 to the body cells, leading to headache and nausea, dizziness, paralysis, and even death. So our answer will be fourth. Carbon monoxide is the right answer. Then after next question, what is it true about RBCs in a human? They do not carry CO2 at all. They carry both CO2 and O2. They transport 99.5% of O2. They transport about 80% oxygen only, and the rest 20% of it's transported in dissolved state in the blood plasma. So answer will be second. They carry both CO2 and O2 is the right answer. Okay. So if I more talk about the second option, so here I would like to say RBCs help to remove carbon dioxide from the body, which is the byproduct of a many chemical reaction in the cells, and the percentage is around 7%, and around the 98.5% of oxygen is bound to hemoglobin and carried in the blood. So that is why we have choose the second option is the right answer regarding of this question. Okay, now next question, which about how carbon monoxide emitted by So, how carbon monoxide emitted by automobile prevent transport of oxygen to the body tissue? So, first, by forming a stable compound with hemoglobin, yes, this is right because this make a more stable compound compared rather than oxygen and carbon dioxide. So, this option is the right. By inhibiting exchange of the O2 at alveoli, so this is not right. By changing oxygen to carbon dioxide, this is not right. By destroying the hemoglobin, this is right. So this is also not right. So option only one right is the answer. So you should know about carbon monoxide when inhaled the combines with the hemoglobin more rapidly than oxygen. It blocks the oxygen transport by forming a stable compound carboxyhemoglobin. It is prolonged inhalation may leads to a death. So our answer will be first. Okay. Now next question about the respiratory center. which regulate respirations is located in cerebellum, medulla oblongata, cerebral peduncle, the vagus nerve. So we know answer is just will be medulla oblongata because just I talked already in my previous session about medulla oblongata and pons. They both are the respiratory center. Okay, so respiratory center are located in the medulla oblongata and pons in the brain. They are extremely sensitive to blood concentration of a carbon dioxide and work in a response to reduction or elevation in the level of the CO2 in the body and hence help in the regulation of the respiration. But our answer will be second, medulla oblongata is the more right. Okay, so answer will be second. Then after, next question, mark the incorrect statement among of them. Herringbone reflex prevent the overexpansion of a lungs. Oxygen dissociation curve for the fetal hemoglobin is one of the left side with respect to maternal hemoglobin. When pneumotaxic center transmit the strong signal, then inspiration time becomes shorter. Amount of air left in the lungs after the normal expiration is termed as the residual volume only. Answer will be fourth. Okay, so this statement is wrong and remaining are right. Why this statement is wrong? So you should know about the volume of air which remains in the lungs after the normal expiration, just known as the FRC, functional residual capacities, right? It is equal to the expiratory reserve volume, and the residual volume, it means RC is equal to ERV and ERV and plus RV, and at a FRC, the opposing elastic recoil force of the lungs and chest wall are the in equilibrium, and this is no excretion by the diaphragm or other respiratory muscles. So our answer will be fourth. Okay, so that is why we have choose the fourth option. Okay, then after next question is about which of the following reflex is involved to prevent excessive inhalation inflation of the lungs, stretch reflex, Herringbone reflex, withdrawal reflex, and condition reflex. So answer will be Herringbone reflex. Okay. So now let me talk about Herringbone reflex. So in the wall of the terminal bronchiole and atria, stretch receptors are present which are normally inactive but becomes active when lungs are excessively inflated. Excessive inflation is due to the failure of switch off of inspiration, right? Then after the Herringbone reflex arc then become activated and sends inhibitory signal to the inspiratory center to which switch off inspiration, and this prevent lungs alveoli from overstretching and bursting. So our answer will be Herringbone reflex is the right answer second. Okay, so now next question about chemoreceptor present in carotid and aortic arc are the very much sensitive to increase in PCO2 in atrial bloods, right? Next option is about increase in PO2 in atrial bloods, decrease in PO2 in a venous bloods. Both second and third is the right. So answer will be first. Increase in PCO2 in a atrial blood is the right answer because chemoreceptor in the carotid bodies and aortic arc are sensitive to change in the arterial carbon dioxide, oxygen and pH. The carotid bodies are generally more important in mediating this response and provide the principal mechanism by which mammals sense lowered level of oxygen. So answer will be first. Okay, option will be first is the right answer. Then after next question is about a person's remaining at the high altitudes for year, becoming more and more accumulated to the low PO2 by following except increased pulmonary ventilation, increase in RBCs and hemoglobin concentration, polycythemia, Increased cardiac output permanently. So answer will be fourth. Increased cardiac output permanently. Because studies of the effect of chronic hypoxia can be performed in the laboratory by decreasing either the concentration of inspired oxygen or the barometric pressure in a hypobaric chamber. Is it fine? Then after, nature has provided a third options, high altitudes, which allow for the examination of the effect of a chronic hypoxia in individual under the varying conditions. Thus, studies of a high altitudes physiologists are of interest not only to the mountaineers and aviators but also to physicians, right? So knowledge gained to mountain peaks may give insight into the pathophysiology of the patient, which are cyanotic heart disease and chronic lungs disease. So answer will be fourth. Next question about if the blood does not deliver adequate O2 to the tissue, it is called anoxia, anorexia, hypoxia, hypopnea. Answer will be hypoxia because it is a if a tissue is a having inadequate supply of oxygen, the condition is called as a hypoxia. Hypoxia is a condition in which the body or a region of the body is a deprived of adequate oxygen supply. Hypoxia differ from a hypoxemia in that hypoxia refers to a state in which oxygen supply is insufficient, whereas hypoxia refers especially to state that have a low arterial oxygen supply. Hypoxia in which there is a complete deprivation of oxygen supply is referred to as a anoxia, right? Then after, if I talk about asphyxia, so is a condition of a severely deficient supply of oxygen to the body that arises from abnormal breathing. And an example of asphyxia is a choking. Anoxia is an extreme form of a hypoxia, low level of oxygen in the blood, in which there is a complete lack of the oxygen supply to the body as whole or to the specific organ or tissue region. Pleurisy is the inflammation of the inflammation of the anoxia. Then after, pleurisy is the inflammation of the pleuri, which impairs their lubricating functions and cause pain when breathing. It is caused by pneumonia and other disease of the chest or abdomen. So our answer will be hypoxia is the right answer. Okay. Then after, next question about less oxygen due to high level of a carbon dioxide is called carbon monoxide poisoning, asphyxia, dyspnea, and apnea. So answer will be asphyxia because hypercapnia and hypercarbia is so when you have too much carbon dioxide CO2 in your bloodstream. It is usually happen as a result of a hypoventilation or not of being able to breathe properly and get oxygen into your lungs. When your body is not getting enough fresh oxygen or get rid of the CO2, carbon dioxide, you might need to gasp or suddenly inhale a lot of air to balance your level of oxygen and CO2. This is not always a cause of a concern. For example, if you breathe is a shallow when you are sleeping deeply, your body instinctively react, and you may turn in your bed and wake up suddenly. Your body can then resume normal and breathing and get more oxygen into the body. Is it fine? Then after, hypercapnia can also be symptoms of underlying conditions that affect your breathing and your blood. So our answer is the second asphyxia is the right answer. Next one question is very very important. Which of the following is a not pollutions related disorder? Silicosis, pneumonia, fluorosis, leprosy. Answer will be leprosy. This one is the right because particulate matter from a various processing industries like a cotton dust, iron mill dust, mine dust, flour mill dust, zinc grinding, cement industries, asbestos industry, etc., cause a pneumoconiosis, biснiosis, emphysema, pseudosis, and other pulmonary problem. Most importantly, silicosis. Silicosis is caused by inhalation of a dust containing free silica or silicon dioxide, especially by worker engaged in a mining, pottery, ceramic industry, and sandblasting building and construction industries. So answer fourth is leprosy is the right answer because this will not the polluted related disease. Okay. Then after next question, hiccups can be best described as forceful sudden expiration, jerk, incomplete inspirations, vibration of the soft plate during breathing, sign of indigestions. Answer will be second, jerk incomplete inspirations. Because hiccups can be caused due to various reasons, including swelling, eating food very quickly. This result in the swelling of a too much air along with the food. A sudden involuntary contraction of a diaphragm is observed in such a case, which in turns result in the closure of the vocal cords or for a brief periods of a time. This caused the characteristic sound of a hiccups. Okay, so answer will be second, jerks incomplete inspiration. Okay, this is very important question, dear students. So please try to understand what I'm saying too, and this is very too much important. So I'm again repeat. Hiccups can be caused due to various reasons, including swelling, first of all, eating food very quickly, right? Then after this result in the swelling of a too much air along with the food, and a sudden involuntary contraction of the diaphragm is observed in such a case, and which is turned in result in the closure of the vocal cords, okay, for a brief period of a time. This causes the characteristic sound of the hiccups, right? Then next questions, number of alveoli in the human lungs can be estimated to be approximately what? 100 million, 300 million, 125 million, and 300 million. Answer will be second. 300 million is the right answer because in a 6 adult human lungs, the mean alveolar number was 480 millions, range was 274 to 790 million. Coefficient of variation 37%. Alveolar number was closely related to the total lung volume, right? Which with larger lungs having considerably more alveoli. So answer will be second, 300 millions, not a billions, this is a millions. Next one question is the very important and good questions. Which of the following can be termed as the opposite of the Bohr effects? Haldane effects, Hamburg phenomena, Herringbone reflex, none of this. Answer will be Haldane effects because Bohr effect, hemoglobin oxygen binding affinity is the inversely related both to the acidity of blood and the concentration of the carbon dioxide, and the Haldane effect is a property of a hemoglobin first described by John Scott Haldane. Deoxy Deoxygenation of a blood increases its ability to carry carbon dioxide. This property is called as a Haldane effect. So here Bohr effect talk about the affinity of a oxygen which depends on the acidity and concentration. Haldane effects is about the affinity of hemoglobin to carbon dioxide when there is a deoxygenation of the blood. So answer first is the Haldane effect is the right answer. Okay, I hope you'll understand. So dear students, that was today's sessions, and really I'm very happy to teach this chapter with fantastic and very good awesome question. Okay, so thank you for watching to me. Bye bye. We will meet tomorrow with topic will new and questions will also different. Okay, so bye bye, take care.